All right, we're looking at case number 6 of, and this is an example of arc z minus z1 on z minus z2 equals to theta. In this case, theta is positive and theta is actually obtuse. So according to the theory recorded in separate video, what this is, when theta is non-zero, then it's an arc. And it's either a major arc or minor arc. And the arc is either above the interval or below the interval, joining Z1 and Z2. And in this case, because it's obtuse, it's a minor arc. It's positive, the angle, so it's above the interval. And so it looks like this. 10 is over here, that's a Z1. 2 is over here, that's a Z2. It's a minor arc, so it's an arc joining that. It's part of a circle, which we're going to find out where the center is, because that's what the HEC question has asked. HEC has never asked obtuse angle before, nor have they asked negative angle before, but there comes some time when they will. But anyway, this angle in this case is 2 pi on 3, according to the question. And so this is your Z1, like I said, this is your Z2. So your Z1 is 10, your Z2 is 2. And then the center is somewhere here. And then you're going to have to ask to find the center of the circle as well as the radius of the circle. So as in this is part of a circle, that's lie on the arc. One property in geometry is that from the center to the middle of the chord, this is the chord, and if it's center, then it splits this into 2. So that's 10, that's 2, so that's the distance is 8. So split in half, that's 4 and 4, the distance. But the theory says that if you split that in half, joining from the center of the chord, bisects the chord, so in other words, that's 90 degrees. Another property of circle is that, so this is that the angle at the center of the circle, namely in this case, is like this. This is your major arc, minor arc here. That's the center. The angle at the center will make half the angle of here. So if this is 2 pi on 3, if this is 2 pi on 3, this angle here will be 4 pi on 3. But another property of circular geometry also is that this is a cyclic quadrilateral, so that the opposite angles of the circle add up to 180 degrees, or in other words, pi radians. Seeing that this is pi on 3 already, this will also be pi on 3, because when you add pi on 3 with 2 pi on 3, it's they become pi, which is supplementary. So these two angles are supplementary. So in other words, the angle that you have over here is going to be pi on 3, opposite side of the circle. Which means what? And you use the another theory of circular geometry. That is, the angle at the center is twice the angle at the circumference subtended on the same arc. In other words, if you have a circle here, the angle at the center there is twice this angle there. So if you look from that view, if this is at the circumference, that means this angle here will be 2 pi on 3. But then you split that in half, so that becomes pi on 3. And so you have a triangle here, if you like, a right angle triangle here. And I'm going to label this. So let's call this point A and this point B, let's say. Then you have a triangle here. You have a look. So there, and there. That's A, that's C, that's B. This is your radius, CB, right? This is what you're looking for. Let's call it H. This is pi on 3, and this is 4. Now, this is basic year 9 trigonometry. So if you use trigonometry, basic SOHCAHTOA, what you get is 4 over H is equal to tan of pi on 4. So tan of pi on 3 rather. Tan of pi on 3 is 4 over h. So h is nothing more than 4 tan of pi on 3. This is where your year 11 exact ratios are going to come back and bite you. Tan of pi on 3 is actually root 3. So h is actually 4 root 3. R, using trigonometry again, so 4 divided by r, so that's opposite and that's hypotenuse, I think. You get sine pi on 3. You have to know what sine pi on 3 is. Sine of pi on 3 is basically root 3 on 2. So basically r then in that case is just going to be 8 on root 3. So you found the radius. Right? Now to find the center is just the midpoint between these two. If that's 8 units, that's 4 units. So from 2 to 4 units along, that's 6. So the center is actually 6. And you go down 4 root 3 units down, by the way. So this must be minus 4 root 3. So that means that your center is 6 minus 4 root 3. And your radius is 8 on root 3 units. And so that has been a past HSC question. But like I said, they've never asked obtuse angle before. They've asked acute angle before. And that's how you find the center and the radius using circle geometry here, as well as here. That is the opposite angles of quadrilateral supplementary, and the angle of the center is twice the angle of the circumference. So if that's 2 theta, so if that's 2 pi on 3, this will be pi on 3. And then using trigonometry to find out where the center radius is, and that's why I'll stop.